Examples for vertical motion under gravity. Number 1. Using the equations S equal to ut plus half gt squared. U is 0 because it's released. Part A, in the first second, S1 equal to half g times square of 1, which is equal to half times 9.81 equal to 4.91 meter. Part B, in the first 2 seconds, the total displacement S2 equal to half g times square of 2, which is equal to half times 9.81 times 4 equal to 19.6 meter. For part C, the distance traveled during the second second is S2 minus S1 equal to 19.6 minus 4.91, which is equal to 14.7 meter. Question number 2. Let's take upward as positive. We have initial velocity u equal to 25 meter per second. For part A, apply the equations v squared equal to u squared plus 2as. We have v squared equal to u squared minus 2gs. Therefore, at the greatest height, we have v equal to 0. Therefore, 0 equal to 25 squared minus 2 times 9.81 s. The maximum height is equal to 31.9 meters. For part B, let the time for the ball to reach the highest point be t. We have v equal to u minus gt. Therefore, 0 equal to 25 minus 9.81 t. The time taken is t equal to 2.55 seconds. For part C, let the displacement be s and the velocity be v. We have s equal to ut minus half gt squared, which is s equal to 25 times 2 minus half times 9.81 times square of 2. Therefore, s equal to 30.4 meters. And the velocity will be equal to v equal to u minus gt equal to 25 minus 9.81 times 2. Therefore, the velocity is 5.38 meter per second. Question number 3. The path of the ball will be initial, moving upwards, and then moving downwards. If we take upward as positive, then we have the initial velocity u equal to 12 meters per second. By applying the equation of motion S equal to ut minus half gt squared, we have S equal to 12 times 4 minus half times 9.81 times square of 4. Therefore, S equal to negative 30.5 meters, which means that the height h of the cliff is equal to 30.5 meters. For part B, let the speed of the ball just up before it hits the ground be v. We have v equal to u minus gt, which is equal to 12 minus 9.81 times 4. v equal to negative 27.2 meter per second. The negative sign means just before it hits the ground, the ball is moving downward. Therefore, the speed of the ball just before hit the ground equal to 27.2 meter per second. Question number 4. Part A. The acceleration due to gravity in the planet is the slope of the VT graph, which is equal to 12 over 2 equal to 6 meter per second square. The physical meaning of the area in region 1 represents the upward displacement, and the area in region 2 represents the downward displacement. If we let the upward displacement be S1 and the downward displacement be S2, then we have S1 equal to 12 times 2 over 2, which is 12 meters, and S2 equal to 30 times 5 over 2, which is equal to 75 meters. Therefore, the height of the cliff h would be equal to S2 minus S1, which is equal to 75 minus 12 equal to 63 meters. Question number 5. For part A, the slope of VT graph represents the acceleration. Since acceleration due to gravity is independent of the mass of the body, therefore, even though a heavier object is released, we have the same VT graph. Because A equal to G again, for part B, if the object is projected vertically downward, that means the initial velocity of the body, u, is not 0, but in fact it is greater than 0 because downward is positive. Therefore, we have the graph. Notice that the new graph had the same slope as the previous one because the acceleration is still equal to g. Part C. If the object is projected vertically upward, that means u is smaller than 0. That means u is negative. Hence, we have the new graph. Again, the new graph had the same slope as the previous one because A is still equal to G. For part D, if the object is released on the moon, since the acceleration due to gravity on the moon is smaller than the acceleration due to gravity on the Earth, that is, G on the moon is smaller than G on the Earth. Therefore, we have a smaller slope and the new graph will like this one. Because A equal to G on the moon smaller than 9.81 meter per second square. Question number 6. When the ball is released above the ground, it rebounds to the same height. If we locate the positions during the path be A, B, C, D, E, etc., the corresponding positions on the VT graph will be A, B, C, D, E. The time just after its second rebound is at D. Therefore, on the time axis, this is the point where we have second rebounds. For part B, if after each rebound the ball reaches a smaller height, the new VT graph will be notice that the slope of the graph during its free-fall motion are still the same as before, which is equal to the acceleration due to gravity, which is equal to G.